Okay, welcome back everybody. Today we're going to continue the second part of lesson 1 from this chapter. Yesterday we talked about functions, kind of what functions may look like, how you can determine if a relation is a function. One of the big points from yesterday is that a function is a special type of relation where every input is matched up with only one output. Each input number can only have one output number, and that's what makes something a function. A function is a type of a relation, so everything that we deal with is a relation, but only special relations get to be called functions. They have to kind of follow some rules. So today we're going to kind of build off of that, and we're going to look at some other things you can characterize about functions. For example, you can talk about what is the domain and range of functions. Now, when we say domain and range, these are words maybe you've heard before just in regular life or school, but they do not necessarily mean the same thing that you've typically used them for. So when we're talking about domain and range of a function, what is the domain? The domain is all of the possible input values, all of the possible x coordinates, right? All of the numbers you could potentially plug in for the letter x or the independent variable, which we're going to talk about a little bit later in this video. Right? These are all the numbers that you could put into the problem. And then the range, now I know you've heard the word range before in a math class, but typically when you've dealt with range in a math class, you're like, oh wait, I know what that is. That's when you take the biggest number minus the smallest number when you have a whole list of numbers. Okay, that is true, but that's like the range of a value set or the range of a data set, right? A set of numbers. This is not the same thing. This is a different type of range. This is range of a function. And we're talking about domain and range. This time, the range means all of the possible output values or all of the y coordinates, right? When you have an x coordinate and a y coordinate, this is going to be a list of all the y coordinates or the dependent variable. So that's the big difference. It's going to give you some different ordered pairs. It's going to maybe give you some tables. It's going to give you some maps. It's going to give you some graphs. And it's going to ask you, what is the domain and what is the range? So you know what? Let's practice some of that because just seeing it on paper isn't always as easy as seeing some examples. Okay, so here's what I'm talking about. When they give you a graph and they're going to ask you, oh, sorry, there's the bell. They're going to ask you, hey, find the domain and find the range. Don't be overwhelmed by this. It's not too bad. Find the domain and find the range. Okay, remember, the domain is a list of all the x coordinates, all of the inputs, right? The independent variable. And so on this first one here with the orange dots, you only have certain numbers that you could call the domain, right? The domain is going to be all of the x coordinates, right? If I made you tell me what are the names of each of these points, right? Like what is the coordinates, the location of each of these points? It looks like this one is at 1, 2, 3, 1, 2, 3, 4. See how this point way up here is at the point 3, 4, right? And then this dot right here is at 1, 2, 1 to the right and 2 up. This is like 5th and 6th grade math, right? This one is at -1, 0. And then this one is at, oh geez, -3, -2. Now, because these are all separate dots, 4 completely separate dots, this is called a discrete graph, but that's not anything you really need to know today. The domain, I'm just going to put a letter D, and some people use these little braces. The domain, I'm just going to list all of the, remember what the domain is, all of the x coordinates. And so I have my x coordinates here. The x coordinate, remember, is the first number in each ordered pair. It goes in alphabetical order. The x coordinate comes first, the y coordinate comes second. So the x coordinate on this one is -3. And usually when you do this, you go from smallest to biggest if you can. And then the next one is -1. And then the next one is +1. And then the last point has an x coordinate of +3. And that's it. That's the domain. You just list all of the x coordinates in a list like that. That's not too bad, is it? Now let me do the range, kind of the same style. For the range, it's a list of all of the output values, a list of all the y coordinates. So I've already done all the work. The y coordinates are just going to be the other parts of the ordered pairs I haven't listed yet. So for like this one, I said usually you go from smallest to biggest. You see what we have here? This one has a y coordinate of 2. This one has a y coordinate of oh, that's -2, sorry. Of -2, let me go ahead and do that one first. And then this one has a y coordinate of 0. This one has a y coordinate of +2. And this one has a y coordinate of 4. And so that is a list of the domain and range. It kind of looks a little bit funky in those little braces, but that's how you do it. Domain and range. Usually you go from smallest to biggest, or least to greatest if you can. If you don't do that, it's not the biggest crime in the world, but people may look at you funny if you don't go from least to greatest. Okay? Now, if you've got that, let me just kind of erase this so I have a little room. What about my second graph here, where now it's almost like a line segment, right? It's connected with dots on both sides. All right, this is more of a continuous graph because this isn't just 4 separate points, boom, 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 boom. Now it's everything in between here and here. And I can't list every single number that's in there, right? Think of all the decimals, 0.001, 0.0002, 0.0003, 0.00. There's an infinite number of numbers in there. I can't list every single number like we did on the last one. So this time we'll kind of just make a range. When you're talking about the domain, remember the domain one more time. The domain is a list of all the possible input values, the x-coordinates. So another way to think of it is how much of the x-axis does this graph use? All right, think about your x-axis. This is the x-axis, right? The one that goes side to side. This graph starts here at, what is this, -2, and it continues all the way, and this is just freehanded. It goes all the way from here to here, right? I'm just kind of drawing the distance. This isn't like an official measurement or anything. The x-axis, our graph kind of lives at this part of the x-axis, right? So I could say my domain on this one is going to be from this point, -2, all the way to this point, +3 on the x-axis, right? The domain is from -2 to +3. Now let me make sure I'm going to write this correctly because there's kind of some funky ways to write it. Okay, so remember how we wrote these things with kind of like the fancy symbols in the last chapter, where we'd say like this thing starts at -2, and remember this had to be a less than symbol, and then you can put x, and then you put the other one as a less than or equal to symbol, and this thing goes all the way out here to 1, 2, 3, right? Goes to 3. So this graph lives at all the numbers on the x-axis between -2 and +3. That's where this graph is located. It's located between -2, 2 to the left, and then 3 to the right, 1, 2, 3. That is the domain of this one. So this is a little bit more complicated. We can do the range the same way, right? The range is a list of all the y-coordinates. Where does this graph live on the y-axis? Okay, so if I'm looking just at the y-axis here, let me use blue marker here. How far up and down does this graph go? Well, here's the lowest point of the graph right here. And then this thing continues going up all the way until it hits this height, which this height is right here. So this is the y-axis, right? This is how tall this graph is. This graph's low point is right here at -1 on the y-axis. The high point of the graph is way up here at this is +2, isn't it? Because this is 2. So this graph has a low point of -1. It has a high point of -2. And so I could say the range has a low point of -1, same symbol. Now we're going to put a y in here because it's on the y-axis, and it has a high point of +2. Okay. Now the reason, why did we have to write this one all weird and we didn't have to write the other one all weird? Well, the reason is because this was a line, right, where the other one was just 4 separate dots. When it's just 4 complete separate dots, you can just make a list. But here, I can't list every number that's in between here and here. There's so many numbers in between here, I can't list them all. So you just have to say, hey, the domain on the x-axis, it went from -2 all the way to +3. That's how far to the left and to the right it went, right? And then the range is how tall is this thing? Well, it starts here and it goes all the way up to here. It starts at -1 on the y-axis, and the high point is at +2 on the y-axis. Okay. Let me go ahead and do the same thing on these last two, just to kind of clear up any confusion you may have. This last one is yellow, but it is still the same idea, right? We have these dots kind of making a V-shaped or a parabola shape. Remember, I could, since these are 5 separate dots, I can just kind of put the coordinates of each one. This is at the point 2, 4. This is at the location 1, 2. This dot is right at the origin, 0, 0. Kind of hard to read there, I apologize. This one is at the point -1, 2. And this one is at the point way up here at -2, 4. Okay, so I have my 1, 2, 3, 4, 5 points. Remember, the domain is just a list of all of the x coordinates. And so the x coordinates that's going to be the first number in each parentheses, -2, -1, 0, 1, and 2. Easy. Because these are separate dots, I'm just going to put them in a list. The range is all of the y coordinates, the second number in each ordered pair here. Usually go from smallest to greatest, and some of these repeat themselves, don't they? The smallest number here is 0, and then we have 2, and then we have 4 again. So we have 2 2s and we have 2 4s. I'm just going to put 0, 2, and 4. You don't necessarily have to list that number 2 times. See how we have 2 number 2s, one right here and one right here? Just put it once. We have 2 number 4s, one right here and one right here. Just list it one time, and 0, 2, 4 is the range. Okay. Easy. I like those the best. This one down here, kind of the same style of shape, but the design of the graph is different. It's different in a way that's going to make us write the answer kind of similar to what we did up here. Remember, the domain and range, whenever you have an entire line, or in this case a line segment, this isn't actually a line. Remember, you're just going to look at the entire graph. The domain, how far left and right, how much of the x-axis does this graph use? Okay, here's the farthest left point right here at the number 1. How far to the right does this go? It goes to right here. That's the number 5. So this graph is on the x-axis. It kind of lives between +1 and +5. So I'm going to say between +1, less than or equal to symbol, less than or equal to symbol, 5. Is it always going to be the less than or equal to symbol? Yeah, unless for some reason these were open circles. If these were open circles, then I wouldn't have the underline underneath it. But otherwise, you'll always do the less than or equal to symbol. And then for the range, I did that in blue last time. Let's use blue again. The range is going to be how tall, how much of the y-axis does this graph use? It starts, the low point of this graph is right here at 0. The high point of this graph is way up here at 4. So this graph kind of lives in this area, right? It lives from 0 all the way up to 4. It's never going to go any higher than 4. It's never going to go any lower than 0. So this is on the y-axis, so I'm going to put a y right here. It lives kind of between, it's located between 0 and 4 on the y-axis. All right? Okay, that is almost it for this video. I'm going to just do really quickly the very last piece. This is more of a science lesson that gets stuck into our math book. They're going to ask us, hey, identify the independent and dependent variable. Now, I know you've learned this in science class, and you may have your own way to keep it straight in your brain, so I don't want to confuse you, but here's how our math book defines it. Independent variable, it's the input, right? Independent is the input. It's the x-coordinate, right? It's the x-coordinate. It is the domain, all of these things, right? A list of all the x values. It can be any number. You can select any number for that. It's what you are plugging into the problem, right? When it gives you an equation, it's what you're going to plug in to the problem and then work it out. The opposite of that is the dependent variable. The dependent variable depends on the independent variable. Some people say that's what you're measuring. It is the output. This is going to be the y-coordinate, usually, if it gives you an ordered pair, right? This is going to be the range. This is going to be your answer whenever you plug something in, work it out. So let me show you what these will look like. They'll say maybe something like this. In the equation y equals -3x plus 12, this represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps of juice, right? You're super thirsty, whatever the case may be. You're going to drink something, and it's going to ask you in this equation which is which. Okay, I just told you. Double check. Independent variable is the x-coordinate. It can be any number you want, right? You could take, in theory, you could take any amount of drinks you wanted here. So the x-coordinate is right here, right? What is the independent variable? The independent variable is the letter x, the input. You could plug a number in right there and work it out, right? Plug 2, plug 3, plug 4 in there, work it out. Multiply it by -3 and then add 12. So the independent variable is this, right? Not just the x. What does x represent? The x represents the number of gulps or the number of drinks that you're taking out of this bottle of juice or something. And then the dependent variable is going to be the range. It's going to be the answer. It's going to be the y-coordinate. What does y represent in this scenario? Look, it's right here. The amount of juice remaining, right? The y is the amount of juice remaining in fluid ounces. So this is the amount of juice remaining, and I could put in fluid ounces if I wanted to, but I'm going to run out of room. So I'm just going to say the amount of juice left over because you've already drank some out of the bottle. So that's basically what you'll do on these. Here's another example. Down at the bottom, T equals 19M plus 65. This represents the temperature. T stands for temperature. Oh, sorry, my hand kind of smeared it there. Temperature in Fahrenheit is what that says. In Fahrenheit of an oven after preheating it for M amount of minutes. So what is the independent variable and what is the dependent variable? Remember, the independent variable is going to be where the x coordinate usually is. It's what you're going to have a number when you plug something in. Now this one doesn't have an x and a y, it has a t and an m, but this is where you would plug a number in, right? This is going to be your input. We could determine how many minutes we leave the oven on for. And so you can see it right here. The letter M is right here, minutes. How many minutes you've preheated the oven. So the independent, you can choose how many minutes to preheat the oven, 10, 5, 4, 3, whatever, 20. And then what's going to be the independent variable is this, what you're measuring, right? And this is the letter T. T stands for the temperature in Fahrenheit, although you can't see it because it got smeared. The temperature of the oven. And so the temperature depends on how long, the number of minutes that you've had the oven on, preheating. So the temperature is going to be the dependent variable. You can choose how many minutes that you want it, and then how many minutes it's on is going to affect the dependent variable. The temperature depends on how long you've had it on. Okay, this video is about 16 minutes, so I need to stop right here, and I will post this to YouTube, and then we will use this to do some questions today. Thanks for watching, guys.